Ever seen the enumerate keyword in Python and wondered exactly what it's doing for your code? Let's break it down so you can master it today. In professional code, imagine you have a list of names. We know it's a list because of these square brackets. Standard practice uses I as the index when you want to loop through the length of this list. This range defines the length. Then we access items by index. Here, the letter I tracks the position, while the name variable pulls data directly from your original list of names. You're manually looking up an index. Running this gives an output showing each name alongside its specific numerical index position. But notice, you're manually calculating that index. That's the manual way. Now, look at enumerate. With enumerate, you simply wrap your variable name inside the enumerate function call. It's a built-in constructor. Notice here that both I and name act as temporary variables. They are placeholders. Enumerate works its magic by returning a special object. That returned object is called a tuple. A tuple is a very simple object. Here, you can deconstruct it. By placing I and name there, you capture the output and assign it instantly. It automatically provides the index in that first variable. The second variable receives the actual value of the item. In this case, the person's name. Running this, we see the results. You don't even need the length keyword or range. Class to calculate the size before looping through. Enumerate handles that automatically for you. The advantage here is massive. It provides automatic indexing and extracts values in a clean fashion, which you can then access directly like this. It simplifies everything for you. Clear, right? Next time you see it, you'll know exactly why it's used. It handles the index and the name automatically. Forget about that clunky old syntax. That is the whole point of it. It was designed to make the manual pattern obsolete. And this cleaner version, the standard? Of course, in programming, no useful method is truly obsolete. The old way still works, but this is a much more elegant way to handle your data loops. As with all things in code, there are many ways to reach your goal. Let's cover a quick but essential Python tip. Ever need to handle two separate lists at once? Here we have student names and their scores. Notice that the score for Sam is currently missing. We want to iterate through these values. Without messy indexing or complex syntax, the zip function is your best friend here. We'll use the zip constructor to pair them up. Simply pass in the names and the scores. Note that these lists are unequal lengths. One list has 3 items, the other has only 2. Zip returns the paired name and score for us. These variables hold our data temporarily. Name them anything you like. The zip function powers our loop effortlessly. Check out the loop. We're iterating through this entire collection. Let's print every name and score combination. What happens if the lists don't match up? The items are clearly different lengths. Running the code reveals the result. It only outputs James and Bob. Sam has been skipped. Zip's superpower is its automatic handling. It stops the moment a pairing is no longer possible. It pairs James with 85 and Bob with 90. But since Sam has no score, the process stops. It won't process him. That is a huge advantage for mismatched lists. Zip lets you loop through data without worrying about index errors. You can see how efficient this is for our project. However, it can be a hidden logic trap. It automatically excludes unmatched items like Sam. That's why you need a proper safety check. Verify that the list lengths are equal before you ever run the zip function. Always print a clear alert if there is a data mismatch in your lists. Comparing the lengths works perfectly. Stop the execution if the data is incomplete. Handle this using a simple if-else block. Let's structure the code like this. If they don't match, trigger the alert, test it with a score but no name. Now, Sam is included in the output correctly. No errors, everything looks clean. But if a name is missing, the alert fires instantly. Python list comprehensions. Let's break this down. We have a list called row names. This variable holds our collection of names. Notice one entry here is essentially empty. It's just 3 spaces, 3 blank characters. Our first goal is to create an exact copy. Check out this clean syntax. We define name then, loop for name in row names. We are extracting each value by iterating through the entire list. It's a standard for loop. For every item in the original, we want to grab that name. Then we store it in our new variable. The square brackets are what make this a comprehension. Python will systematically extract each item. It pulls one entry, adds it to the new list, and moves to the next. Running this gives us a perfect duplicate. But the real power of comprehensions comes with advanced logic. Look at this updated version. We still have a list. We still have our loop. For name in row names, that part stays the same. But now we can add a condition. This is where it gets very interesting. We've added an if statement stating, if the name after stripping away the spaces is not empty, keep it. Otherwise, ignore it. We only want names that contain actual characters after cleanup. Why use the strip method here? Look closely at Kate. She has extra spaces. Amy and John are already clean. And then there's that blank entry with spaces. Strip removes those messy gaps around Kate's name. In our first copy, those spaces tagged along. But this expression allows us to refine the data before it's even stored. Two things are happening. First, we aren't just copying. We're deleting anything that is just empty air. We don't need that, like this entry right here. Once we have valid names, we polish them using strip. Now, look at the final result. The spaces at the start and end of Kate's name completely vanished. Run the code, and Kate is now perfectly clean. No more messy margins. That's the magic of this part. Before it hits the list, it strips the spaces. And that empty entry, it's totally gone. Our if condition filtered it out instantly. The core syntax is simple, but adding expressions changes the game. You can manipulate and transform data. Total control. Filter your results before they reach the final list. I hope this cleared things up. That's the logic. Here is the basic way, and here is the pro-level logic with transformation and smart filtering working together. Ever needed to categorize data instantly? Imagine you have a list of scores and need to tag every pass and fail automatically. How do we solve this? Python list comprehension is your secret weapon. Check this out. List comprehension allows us to process an entire loop in a single line. We iterate through the scores using an item variable to check every single number within our original scores list. The goal is to scan each entry and apply a simple rule. Return pass if the score is over 50, otherwise return fail. This is a concise logic check. Ready? Running the code, you can see the first entry is marked fail, because 45 does not meet our requirement of being over 50. However, the next two entries pass the test, while the final score of 30 is flagged as a fail. It is a simple, effective way to filter results. That is where the else condition kicks in. Now, let's look at the zip function right here. This pairs our scores and labels together perfectly. Think of it like zipping up a file. It locks two separate sides into one. That is the power of zip. Just like zipping up a jacket, you are bringing two distinct parts together. That is exactly what is happening here, combining data into clear pairs. When you run this, you get a list of tuples. 45 is a fail, 80 is a pass, 60 is a pass, and 30 is a fail. You can see how useful the zip function is when paired with list comprehension to create this clean output. Essentially, you're taking two separate lists and merging them, just like a zipper. Two parts becoming a single unit. Just remember the format. Place the success value first, then the condition, followed by the alternative value. This is known as ternary syntax, a shorter, cleaner version of an if statement. It replaces those long, bulky blocks of code. This expression evaluates quickly and returns exactly what you need. The true value is right here. If the condition matches, it is selected. There is no need to write full if statements for logic this simple and elegant. Mastering Python starts with sorting. It is as fundamental as brewing your morning tea. Take a look at this collection of numbers. We have them stored inside this variable. In Python, this data type is known as a list. Python provides a sleek sort method that instantly organizes this list in ascending order. Once we run this code, you can see our numbers are perfectly aligned. Simple, right? But what if you want to flip the script and reverse them? You might be wondering how to pull that off. The sort function actually includes a powerful parameter you can use called reverse. If you hover over the code, you will see the sort method waiting for that reverse argument. It looks for a Boolean value, and by default, it is set to false. By switching that value to true, you command Python to sort everything in descending order, ranking them from highest to lowest. Now, when we run it, the largest number takes the lead and the smallest finishes last. To recap, leave the parameters empty for ascending order, placing the smallest values right at the front. But notice something critical. This process actually overwrites your original data. This is what we call in-place sorting. Your original variable has been permanently transformed. The same rule applies here. The original sequence is gone, which is a problem if you need to keep that data intact. If you want to preserve your history, avoid the standard sort method. It changes the source material forever. It alters the original order. Instead, you should use the sorted function. The sorted function uses a very similar syntax. Once again, you have access to a reverse parameter that defaults to false. Watch as we pass in our prices list. But pay close attention to the left side of equals sign. We are creating sorted underscore prices. This creates a brand new variable. When we execute this, our original list remains exactly as it was, while our new list, stored here in this sorted underscore prices variable, has been beautifully organized from smallest to largest. So if you need to keep your source data completely untouched, sorted is your best friend. But if you're fine with modifying the original list, stick with the sort method. Keep in mind, sorted uses more memory because it is managing two separate lists. The definition of the sort method confirms it works in place. The list itself is being modified. With the sorted function, the return type is an entirely new list. It generates a fresh copy containing every item in perfect ascending order. Get ready to master one of Python's most surprising behaviors. Let's decode it and unlock a powerful new skill together. How do you think Python will sort this specific list? Watch what happens when we run the standard sort function. Surprise! Bob and David appear before Amy and Charlie. Why does this happen? It makes no sense. No human would ever sort a list this way. Python does this because uppercase letters like B and D come before lowercase letters like the ones in Amy and Charlie. Not what you expected at all. Sorting like this will easily frustrate your users. How do we fix this? Any bright ideas? Can you figure it out? Without expert Python knowledge, you will lose this battle every time. But here is the secret. Let me show you how. Let's bring back our list. This time, watch closely as I use the powerful key parameter. This parameter lets you define exactly how Python compares values. We are going to take every single item from this list right here and apply the string lower function directly. This converts everything to lowercase before sorting. Notice that we are not adding parentheses at the end here. That will fail. Instead, we simply pass the name of the function we want to run. This function belongs to the standard string class, built right into the heart of Python, and we are handing it the lower function. It instantly applies to every single item in the list. Now, when we run this, you can see that Bob, Charlie, and David are perfectly sorted. Exactly as expected. Just remember, you only need to provide the function name for Python to process every item automatically. Every item gets converted to lowercase before sorting begins. Never forget that capitals always come before lowercase letters by default. So always convert them to all lowercase or all uppercase first. This simple trick gives us the perfect result right here, completely avoiding that messy output from earlier. I hope you found this Python sorting trick highly valuable. It is incredibly simple once you know it, but a massive headache if you do not. Let's explore a powerful way to sort through complex data. Imagine pulling dynamic records from a database or an API. You receive a clean list of dictionary items. Each dictionary holds a person's name and their salary. Now, let's say you need to sort this entire list by salary instead of by name. How do we achieve that? Who earns the least and who brings home the most? Ideally, Sarah should come first based on her earnings, followed by Emma, and finally John with the highest pay. When we run this script, notice how beautifully It orders them, Sarah, then Emma, and then John. But what's happening under the hood? Let's look. This syntax might look a bit intimidating at first. You might wonder what in the world is going on. Let's break it down. The sort function allows us to specify a custom key, and the key we want to target is the salary field. To do that, we can simply pass in a mini function. This keyword, lambda, means create a quick function. Its input will be the employee object, representing each worker in our list. Starting right here with the first one, after the colon, we extract just their salary information. So for each employee, we pull the salary. That is exactly how we access dictionary items in Python. Running this instantly gives us perfectly ordered data. Now Emma is at the top of the list, followed by John and finally Sarah. All of this magic happens just by using a simple lambda expression. To recap this brilliant piece of syntax, lambda literally means create a function. Next is the variable. That's our input parameter. Name it whatever you like. Then comes the colon. The colon separates the input from the output. Input goes on the left, output on the right. This is what gets returned, so employee salary is the final result of this function. If we rewrote this lambda as a standard function, it would look exactly like this. GetSalary takes the employee input and simply returns their salary. Then you can use that function right here. But with lambda, we don't need to create it elsewhere. Instead, we are building an elegant inline function, a sleek, anonymous function that executes and vanishes. No need to define a whole separate function for this. Just remember, lambda creates a function, followed by the input parameter, a colon, and finally the output that gets returned. At first glance, this syntax looks pretty strange. You're probably wondering what on earth is happening. Don't sweat it. It's actually incredibly easy once we break it down. Stick with me here. Python's sort method accepts a special parameter called a key. This key is just a function that Python runs on every single element you give it. In our case, it's processing these items right here. Notice we are using lambda here. That keyword simply means create a brand new function. Its input is just the letter x. This x represents each individual element. We could name it anything, but let's keep it simple. With x as the input, Python passes every single element into our function. Everything before the colon is the input, and everything after is the output. And here, the output is a powerful data structure called a tuple. Tuples in Python are wrapped in standard parentheses. This tuple extracts the name and age from each element. Position 0 grabs the name, and position 1 grabs the age. Now, Python will execute the sort directly on these tuples. Once sorted, check this out. Amy appears twice. We have a younger Amy and an older Amy. The younger Amy is placed first, followed by the older Amy, and finally Bob comes last. A flawless ascending order sort. But why does this work so perfectly? It works because Python compares Amy age 22 directly against Amy age 30. Python can compare them head to head. Internally, it checks the first element of the tuple. Are the names identical? Is Amy equal to Amy? Since they are, it moves to the next element. That brings us to position 1, the age. Right over here, Python then asks, is 22 less than 30? The answer, of course, is true. So when evaluating if Amy at 22 is less than Amy at 30, the result is true. And that's the secret to how Python uses tuples to sort complex data structures with multiple keys. You could use this to sort by first name and then by last name. Remember, it isn't magic. The lambda keyword just creates a quick function. Here is the input, the element, and this is the output for each element. We structured it in a specific order. The name first, followed by the age. Python handles the rest internally, effortlessly checking if Amy at age 22 is less than Amy at 30. It does this by first comparing the names, then moving to the second element to see if 22 is less than 30. Since both conditions are met, it returns true, letting Python sort the elements. I hope this shines a light on how this complex-looking code can be broken down and made super easy to understand. Let's take these database items and sort them like a pro. We're working with a list of dictionary items straight from our data. Each item, like this laptop, has its own specific price attached. Now, let's sort them in descending order. They're currently ascending, but we're going to flip that. How do we do it? Python's sort function accepts a key. This key is a function applied to every single item in the list. As the list is processed, each item runs through this function. Enter the Lambda function, a powerful anonymous function. It has no name. The Lambda keyword creates it, accepting a parameter we will call p. In this case, p represents the current item. It loops through, grabbing one element after another, seamlessly moving on to the very next one. Whatever follows the colon is what this function returns. It extracts data straight from the item p we just passed. Specifically, we are pulling out the price from the dictionary, targeting the price, making it our sorting key. Next, after the comma, we tell Python to reverse it, flipping the order of the results we get back. Since we grabbed the price, it sorts by that. Now let's reverse it. Running this, watch how the laptop instantly jumps to the top, followed right behind by the phone at 800. And finally, the tablet sitting at 600. If I change reverse to false, look at that. The tablet shoots to first place, the phone takes second, and the laptop lands in the final spot. This unlocks the power to reverse order using any custom field you want. Here, we are targeting and flipping that specific price field. Don't let this syntax intimidate you. It's actually incredibly easy to grasp. Lambda creates the function. It accepts a single input, representing each element automatically. Python handles the passing behind the scenes, so no extra wiring needed. We choose what to extract. Whatever follows the colon is what is fed directly into the sorting algorithm. Then we simply flip the switch to sort it in reverse. And boom, you get the perfect, customized result every time.